So let's start. Hello everyone. It's really good to see you here, and it is really good for me being in front of an audience. It's been a long time since the last time I did this. I have to say that I think that this is the first time our company is in Voxxed days. Although we do feel that it is a very important event, and this is why we support it strongly. Not only as a sponsor, but also by taking place in the whole process, listen to what others have to say, see where our favorite technology is heading to, and taking a small opportunity to discuss about some aspects of business software, which is our domain, which we feel sometimes are kind of ignored. And for one time, let's start from operations. Most analysts agree that the development cost of an information system rarely reaches 20% of the total cost of ownership of that system. And on top of that, it is estimated that operational failures of software systems has costed the United States economy $1.5 trillion only in 2020. This is really bad news. This is like someone is telling us that we do not take into account some very important aspects of the systems we build as much as we should. And we feel that the only way we can turn this around is to make these features first-class citizens into the design and development process. We need not to design not only for function, we need to design for operations, we need to design for future extensions, we need to design for failure events, and we need to put all of our craftsmanship in the building process. And the building process, it's a lot about structure. This is our favorite aspect when we talk about software design. When we observe ecosystems, information ecosystems, we can tell the diversity. We can tell that there is no blueprint in this ecosystem. The funny thing is that information systems are themselves ecosystems on their own. They are ecosystems of subsystems, modules, components, services, etc. So if we follow this path of thinking, we reach the point where we think that there is no information system can be captured by a single blueprint. Let's take the most popular architectural pattern nowadays, microservices. Within each individual service, we most probably notice ports and adapters connecting the individual services into a service mesh. We might also observe layers in the internal structure of the microservice. And if we look at the user interface of the application that follows this architectural pattern, we might see that there are micro front-ends plugged into a kernel, which is the user interface. Not to mention that individual services in this architecture might exchange messages for one to another. So yes, it's patterns all the way down. And the cool thing about design patterns is not only that we can apply them to any abstraction layer, but that contrasted to technology, which is temporal, design patterns are timeless. And this is the big thing about design patterns. And what we are trying to do in our organization is to have a close eye on technology, but we focus on outcomes first, and then we doing trade-off analysis on what technologies are the best to deliver these outcomes. And as long as we stick to our design principles and we apply good design patterns for good reasons, we are free to create hybrid architectures to deliver the functionality of our systems. Speaking about functionality, there is one very popular debate between logic and data. We have dozens of data models. Perhaps we have more data models than we can use in our designs. But when it comes to processing logic, there are only a few models out there. And in most of the cases, we tend not to use them. Perhaps we do this because we think that processing logic finds its home in our code base. That depends. That depends on the kind of logic. If we are talking about business logic, this is not the case. At least this is how we do it in our organization. When we observe high coupling between components, or we measure high cyclomatic complexity, actually we are observing the symptom. The virus is, in most of the cases, the business logic, and it will eventually kill our code base unless we capture the logic into a model. And this is what we are trying to do in our designs. We try to model the logic and then we try to code to the model. Someone might say that, look, this is not something new. This is what all vendors of commercial software are doing. And they are doing this because they have a huge revenue coming out of licenses, subscriptions, royalties, etc. So normal companies that build their own software do not have this revenue stream, so they cannot afford this kind of investment. This is a really nice discussion. We feel that all companies can afford to do that. We cannot fit this debate into this time slot, but we can discuss if you are interested in the break in our booth. We talk about investments, revenue streams, cost, etc. It looks like our discussion shifts from the domain of software technology into the business domain. And yes, this is actually what is happening. And perhaps it is happening into a bigger scale. We, people of information technology, are becoming business people. And if we take a moment and think a little bit about it, we have been business people before a long time, but perhaps sometimes we tend to forget it because of our profession, which is really nice, a really great profession, which is in part science, in part art, and in part business. And if we need to be successful in what we do, we need to play all these parts. And perhaps the last one tends to become very important. Some of the companies around the world are run by software engineers, and that trend will increase. So you need to be prepared for that. This is the kind of mindset we are trying to build in our organization. So I will take some time to give some hints about what Inter-American looks like nowadays. When it comes to change, we have two gears. One for product, which is fast-paced, and another one for technology innovation, which is more controlled. We have a dual working model. We work both on premises when it comes to creative design and collaboration, and we work from home for effective execution. We have a two-dimensional organizational structure, and also we have a dual career path, one leadership path and one professional path. And people can jump from one path to another. We have a lot of different kinds of colleagues, and all together we are working on more than 5 million lines of code in 150 systems and applications. We use a number of technologies to host and run our systems. Some of them are reaching the end of their lives, but some others are about to enter our ecosystem. I don't know if we have time. Okay. Actually, let's give some time for questions. If there are some questions, we can discuss in more details in our booth. We will be glad to see you there. In the meantime, thank you, and thanks the Voxxed Days team for delivering one great event again. Thank you. Okay, if we do not have any questions, we can discuss. I think we have something like 5 minutes or so. I didn't know that. If I knew that, the presentation would be much more in detail.
Hello there. Speaking English, I don't know if there's anyone in English. Okay, one question I would have is, what would you consider, from your experience, a good way, or an optimal, I don't know, to transfer or to communicate business requirements to development teams?
Look, it was a joke. Actually, we didn't want to ask to answer two questions, especially like such as this one. Look, actually, we do two things. Let me go back on one slide. Most of the teams in our organization are cross-functional. So it means that we do not have the notion of an outside party, or usually we call it the business, which has some requirements that need to be communicated to the development team. We have a fully stacked product development team. So we have there the product developer. This is not the product owner. We have the product owners, product developers. In our case, we might have pricing actuaries, underwriting experts, business analysts, software engineers, and in some extreme scenarios we can see IT engineers joining these squads as well. So the main vehicle we have is to write down the stories. In our case, however, in many cases it's not enough because of the nature of the insurance domain, which is one of the most complex business domains out there. In that cases, we follow a more formal description, more formal than story. And if we are talking about a quite complex story or a bigger vehicle of stories like an epic, then we are doing design sessions in order to collaborate and put stuff down and agree upon what the team is going to deliver in the next sprint. This is how we do it.
Hello. I don't know if I have missed parts of the introduction of your presentation. So I found very interesting the fact that you tried to model the business logic. And if I understood correctly, you said that there are not a quite range of business models. So do you have a methodology, or can we discuss a little bit what is the outcome of your investigation? How many business models you have identified? And what are the criteria with which you categorized all the variety of business into different business logic across companies, etc., into such models? Is it something that you have initiated as a company, or is it some theoretical, let's say, research that you have continued its life cycle? Let's call it like this. Thank you very much.
Really good one. Thank you. Thank you for this question. Some quick thoughts. Yeah, there are only a few models. Let's discriminate between business models. We mean how a business is making money. This is a business model, and I was talking about software getting into this domain. But I think that you are referring to models that can capture the business logic. Huh? Okay. Now, in this, as I said, we have only a few abstractions out there compared to the dozens of abstractions we have when we talk about data models. I picked up this slide, which is not the slide of your interest, but it gives one part of the answer. It's patterns all the way down. The way you model, the way we found that it is very suitable for us to model the logic of our domain is things like composite structures, if you are familiar with this design pattern, and some other early mathematical stuff like a state machine, or a workflow engine, or a pipeline, or a list, or a set, things like that. This is the only things actually in our disposal to model logic. Some of them are quite complex to use, like state machines or Petri nets, and very big composite structures, but this is the tools and the abstractions we use. For instance, in our core insurance system, most of the logic of that system is created as a huge object graph, which is actually a composite structure. I don't know if I gave you the idea.
Really, I found it very interesting what you do. And I understand that it is a cross-functional team. What kind of roles are included in this work in progress that you have?
We have, I don't know, 30, 28 cross-functional teams in our organization, perhaps even more, I don't remember. I'm looking at the back of the room where our HR advisor might give me a hit, but okay. We have at least 25 cross-functional teams which are enabled with software delivery skills. And the roles we have is these ones here, among others. In these roles you can add for our domain, actuaries, product developers. Of course, we have sales people working in these teams if needed, marketeers, and what else? Underwriters sometimes, I think. Working together with the rest of the specialties we use in our squads. And when we talk about technological evolution, this is where most of our squads tend not to be cross-functional. In these cases, when we develop for a new platform, for instance, we mainly need technical analysis and software engineering, nothing more. But when we are delivering products and services, we have the full stack in the squad. Thank you very much. Thanks for the question.